this video, we're going to go over characteristics of quadratic equations, being able to look at the equation and get some information from it that will help us graph it. First off, the equation must have two variables in it. Most of the equations, whether they're in standard form or in vertex form, are going to have an x and a y. And one of those variables has to be squared. In all these examples, like I said, we're going to use x and y because that's usually how it's written in standard form or vertex form. They use an x and a y, especially if you're going to graph it. For the equation to be a function, the one that needs to be squared, the one that needs to have an exponent of 2, is going to be the x. Only if the x is squared will it be a function. Only if the x is squared will it open up or down. If the y is squared, it's going to open up left or right. Here's an example. If it has an x squared, it's going to open up or down like this. But if the y is squared, it's going to open up left or right. If the y is squared, they're not functions. If the x is squared, they are functions. Now I need to figure out how I can look at the equation and tell whether or not the function opens up or down, whether or not it has a maximum or minimum. First, we need to put it in standard form. And standard form is y is equal to some number in front of x squared plus some number in front of an x and then a constant on the end. Now sometimes some of these on the end may be missing, but it always has to have an x squared. If the a is positive, then it's going to open up like this right here, and it's going to have a minimum value. If a is negative, then it's going to open down like this right here. This is how the graph is going to look, and it's going to have a maximum. So you look at this first number right here in front of the x squared, and it's going to tell you whether or not it's going to open up like this and have a minimum. If it's positive, that's what's going to happen. If it's negative, it's going to look like this. The graph's going to look like this, and it's going to have a maximum. Now in the previous videos, we went over the parts of a quadratic graph. We went over the vertex, x and y intercepts, axis of symmetry. We're going to go over how you find the vertex if they give you an equation. First, make sure it's in standard form. That means it needs to be y is equal to, and then the x squared, and then the x if it has one, and a constant on the end. Then you're going to use this formula right here to figure out what the x coordinate is. And this formula is derived from the quadratic formula. We're going to talk about that later. But right now, if you just use this formula, you can figure out what the x coordinate is going to be. Remember, in standard form, you have a, b, and c. The number for b is going to go in here. The number for a is going to go in here. You're going to do a little bit of math, and you're going to figure out what the x coordinate is. And we're going to do an example in a second. To find the y coordinate, you're going to take whatever you found for x, plug it back into the equation, and solve it for y. So make sure it's in standard form. Use this formula to figure out what the x coordinate is, and then take that value, plug it back into the formula to find the y coordinate. So let's work an example. Example number 1. I need to make sure this is in standard form where it says y is equal to some number in front of x squared, some number in front of x, and a constant on the end. This right here is going to be my a, this is going to be my b, and this is going to be my c in any formula I use for a quadratic. To find the x value, I need to use this formula, negative b divided by 2a. It's sort of like using the slope formula. This formula is going to help us figure out the x coordinate for my vertex. Negative b means the opposite of b up here. This is negative 20, so when I put it into the formula, a negative and a negative is going to make a positive. Then I need to take 2 times whatever a is. This number right here is going to be my a. I multiply the bottom. 2 times 5 is 10. I divide. My x coordinate is 2. To find my y coordinate, I need to take this and plug it into the original equation. So y is equal to 5 times 2 squared because my x is being squared, and I figured out what my x is. Minus 20 times 2, taking negative 20 and multiplying it with whatever x is, plus 15. I follow my order of operations, meaning I need to do my exponents first. 2 squared is 4. I multiply. 5 times 4 is 20. Negative 20 times 2 is negative 40 plus 15. 20 minus 40 is negative 20 plus 15, and negative 20 plus 15, negative 5. So now I can write my vertex. I can take my x right here and my y right here and write a vertex for this. My x is 2 and my y is negative 5. There is my vertex. And since this is positive, that means it's going to be opening up like this right here. And this point right here will be to negative 5 once I get to the point of graphing it. Right now we're just finding out what the vertex is and using the fact that this is positive. That means my graph is going to look like this, and this point right down here is going to be to negative 5. Next example, they want us to take this quadratic and find the vertex. First thing, it needs to be in standard form, and it looks like it's in standard form. That means this number right here is going to be A, this number right here is going to be B, and this number right here is going to be C. To find the vertex, I need to find the x-coordinate first, and I need to use this little formula, negative B divided by 2A, and it will tell me what the x-coordinate is. This negative B means the opposite of this number right here. A positive 16 becomes a negative 16. 2 times A, that number in front of x squared is 1. Multiply those two together. I get 2, and negative 16 divided by 2, negative 8. Negative 8 is my x-coordinate. Now I need to find my y-coordinate. Find my y-coordinate by taking this number and plugging it into this formula. That means I'm going to take negative 8 and square it, plus 16 times negative 8, plus 71. Negative 8 squared is 64. I then multiply. 16 times negative 8, negative 128, plus 71. 64 minus 128, negative 64 plus 71. I have my x-coordinate, I have my y-coordinate. I can now write the vertex for this. Negative 8, 7. This is going to be opening up like this right here because this is positive. I need to find the vertex for this one. Remember, this needs to be written in standard form. When there's parts over here where you don't have the B and the C, I'm going to write the B and the C by doing this, plus 0x plus 0. So that I can show what the A is. The A is going to be 1, the B is 0, and the C is 0. To find the x-coordinate, I use this little formula right here, and I plug the B and the A in there. This is the opposite of 0. Well, 0 is neutral, so it's not positive or negative. So I put a 0 up there in the top. And then 2 times 1 is 2. 0 divided by 2 is 0. My x-coordinate is 0. To find my y-coordinate, I plug this 0 into this formula right here. 0 squared plus 0 times 0 plus 0. All those are zeros. So y is also going to be 0. My vertex for this is 0, 0. I need to find the vertex for this one. Again, it needs to be in standard form. Plus 0, that's going to give me an A, a B, and a C. I don't have to write this, but you need to get into the habit because other formulas are going to use the C. In this first formula, I'm only going to use the A and the B because to find the x coordinate, I need to use this little formula right here. That means I need to take the opposite of B. It's already negative. A negative and negative make a positive. Then I'm going to take 2 times whatever A is, 4. 2 times 4 is 8. Always put a fraction in lowest terms, 1/2. So you're not always going to get whole numbers on these points. So my x coordinate is 1/2. I need to find the y coordinate. I need to take this 1/2 and plug it back into this formula. That's 4 times 1/2 squared minus 4 times 1/2. 1/2 squared. That's 1/2 times 1/2. I'm just showing what I'm doing right here. 1 times 1 is 1. 2 times 2 is 4. 1/4. 1/2 squared is 1/4. Four times 1/4. 4 times 1 is 4. Divided by 4, this is 1. Negative 4 times 1 is negative 4 divided by 2, negative 2. 1 minus 2 is negative 1. So my vertex for this one, the x coordinate is 1/2, the y coordinate is negative 1. We're not always going to get whole numbers on these. We're going to find the vertex for this one. It needs to be in standard form, and it looks like it is. There's my A, there's my B, and there's my C. To find the x coordinate, I need to use this little formula right here. And I need to plug these numbers into the formula. Negative b means the opposite of this. That's a positive 3, that turns into a negative 3. Then I want to take 2 times whatever a is. Remember, there's a 1 sitting in front of there. This is negative 3. 2 times 1 is 2. My x coordinate is negative 3/2. To find the y coordinate, I'm going to take negative 3/2 and plug it into this formula right here. Negative 3/2 squared plus 3 times negative 3/2 plus 2. Negative 3/2 times negative 3/2. Negative 3 times negative 3 is positive 9. 2 times 2 is 4. So that's what negative 3/2 squared is. Now I need to do my multiplying. This is 3 times negative 3. I multiply the top and divide by the bottom. 3 times negative 3 is negative 9. But I can't take 9 and divide it by 2 and get a whole number. So it's negative 9/2. To add or subtract fractions, I need a common denominator. I'm going to change every one of these to where it has a denominator of 4. This is my minus, this is my plus. The only thing I'm going to do is change these if it needs to be changed to where they all have the same denominator and I can combine them all together. This one hasn't changed. What do I multiply to 2 to get 4? Well, 2. I'm multiplying the bottom by 2. I need to multiply the top by 2. 9 times 2, 18. This can be written as a fraction like this. What do I multiply to 1 to get 4? That would be 4. If I'm multiplying the bottom by 4, I need to multiply the top by 4. 4 times 2 is 8. Now I can combine these together because they've all been changed to where it has a common denominator. 9/4 minus 18/4. is negative 9/4 plus 8/4. I got this by combining these two together. Now I combine it with the last one, negative 9/4 plus 8/4, negative 1/4. So my vertex, my x-coordinate, negative 3/2, and my y-coordinate, negative 1/4.